So again, we're just doing that last objective here. We're going to calculate percent composition. It's actually super easy. You guys know how to do percents already, right? What do you do? How do you get a percent?
Use the percent button on my
You
calculator.
take the part divided by the whole, and then you multiply by.
You might have to refresh it.
So you just take a part divided by the whole, which will give you a decimal number, right? So then to make it a percent, you do need to move the decimal, remember, but that's multiplying by what number? What is the total always for percents? 100. That's essentially what we're going to do for that percent composition, and it just applies with that mass that we talked about, the formula mass. So it's really, really pretty easy to do. If I can figure out where we're at. Okay, so it's the percentage by mass of each element in a compound. All you have to do when I ask you what is the percent by mass of nitrogen ammonium carbonate, well, first off, you got to tell me what ammonium carbonate is, because we don't necessarily know right away. What's ammonium? That was a weird 4. Try that again. And then carbonate.
It's carbonate CO3.
Negative.
And then this has what charge? This has 1 charge.
+1, -2.
Yep, so that means I'm probably going to need 2 of these, right, for every one of those. So ammonium carbonate looks like this. But just like before, I need a total mass. So I would just do what I did before. I'd have 2 nitrogens, which were 14.01. Before we get too far, that does seem vaguely familiar. Did we do that one already in the notes? Ammonium carbonate?
No. Yeah.
Yeah, we did.
Yeah, so we already know what the total is.
96.11 grams.
That's what it was.
Right, and in this case, we don't really necessarily need a unit on that because it could be grams if I want a molar mass or AMU if it was formula mass, but it was like 96.11. But we still need to recalculate this part because how much of that was actually from nitrogen? So this 2 times 14 is still relevant. That's going to be 28.02. So I'm taking the part that is nitrogen divided by the total. I think we double checked that yesterday, so I'm going to think that that 96.11 is probably correct. But what is 28.02 divided by 96.11? And then you got to multiply it by 100. What do you get for that?
29.15.
And that is actually good. I'm not sure if you did that on purpose or not, Morgan, but this has how many sig figs?
4.
This has?
4.
So your answer can have 4, which it does. So 29.15%. And then you'd put a label next to it. It's percent nitrogen in this case. I could do a percent for hydrogen, for carbon, for oxygen in the same thing too, if I wanted to. So I can figure out what percent of that total mass was from nitrogen. And it's 29.15% nitrogen in this case. It's actually really easy to do, not supposed to be hard. It's just get it done. So this one, next example, percent by mass of iron and ferric sulfate. Again, we got to build a formula here first. Which iron is that?
Iron 3.
The iron 3. And sulfate, it looks like what? And it's got what charge?
-2.
-2. So I'm guessing this is going to look like this. I don't need those parentheses around the iron, but whatever. Now again, I do need to do the 2 irons again, but I'm pretty sure we did this one before as well. What was the iron's mass though? It was like 55.93. So I have to calculate that, but then I'm going to divide by that total that we already have, multiply by 100. First off, what's 2 times 55.93?
111.86.
186. I'm going to divide by what was the total last time? 400 something?
0.07. Total of what?
7.
Since we've already.
Is that what you said? 400.07? Okay. So we already did that one once as well, so save some time here. Part divided by total times 100.
27.
I should be around 25% again. It's
27. Actually 28.
And then be careful here. How many sig figs should I have in this answer?
3, 2, 3. 3.
Each of those have 5 sig figs.
Will the zeros count?
Yeah, the zeros count. Remember, they're in between. They're trapped in that case. So I have 5 sig figs in both. I can have 5 sig figs for this answer.
Okay.
Now, a lot of times you don't need that many sig figs. It's just saying, in this case, I can use 5 sig figs.
27.960.
And you need that zero if you're going to have 5 sig figs. And you'd put a percent, and you'd say iron. So it's about 28% iron, 27.960 using sig figs. So just use whatever sig figs you get out of those masses. Again, we always do these 2 places past the decimal, so whatever ends up, it ends up. If it's a small thing like a water, be 18.02, you got 4 sig figs. This is a big thing, so there's 400 AMU grams, whatever. So you get an extra sig fig when it's really big versus really small. Diatomic hydrogen is only 2.02, so you get 3 sig figs out of that. You also wouldn't do a percent mass of hydrogen and hydrogen because it is hydrogen. It'd be 100% hydrogen. So not really necessary in that case. Okay, and then this last thing is a little bit off base from those things we just did. They're not percents per se, but I'm still talking about relative amounts of something in here. So this kind of question is going to pop up, and you're going to have to know how to do it. And it's actually not very hard. You just have to understand the basic logic here. A 1 mole sample of hydrated cupric sulfate. I wonder if I have any cupric sulfate.
This doesn't make sense. 75 plus 4 divided by 3 is 6.33333.
This is cupric sulfate. A pretty blue color.
What
Like
we'll
my
do is
shirt.
put it in water.
What?
We'll do something.
So that'd be a blue solution. It's not pretty, but you guys know when it's copper, especially that cupric. Cupric is which copper? Copper 2 is blue. You can always tell if it's copper 2 because there's that blue color. Copper 1 is actually reddish, so you can tell the difference
So
really
like
easily.
when rapid, there's like that red soil. It's copper 1 in there.
That's clay.
No, there's like
There could be copper in that clay. That would be what makes it red. It could be. I don't know if that's necessarily true because there's a lot of different reds.
or like in the clay. Then when the clay is red, is that because of that?
Shattern State's football field.
You'd have
they
to
put
actually
copper on it to
analyze
make
it
red.
to find out. But
Nebraska Huskers football in on their field. Yeah, they put copper on it to make it red.
so copper sulfate, hydrated cupric sulfate, has a mass of 249.71 grams and is heated to produce 159.62 grams of anhydrous cupric sulfate. How many moles of water are present in the hydrated cupric sulfate? Basically, right, one thing that you can learn about different ionic compounds is a lot of them are kind of hydrophilic, like that one there. So it actually kind of sucks in water from the atmosphere because it just really, really likes water. Happens a lot with something with like sulfate in it because that's an acid. And it's the conjugate of an acid, remember? It comes from sulfuric acid. But, so this has water in that crystal that you're looking at, but you can get rid of that water. So at the end of the day, what do you suppose my first step here is to do? What do you think I need to do first? Get rid of the water. How do I do that? I mean, it said I got rid of the water by heated, but how do I find out how much water there was?
Measure it.
already got two numbers up there. What am I gonna do with them?
Item.
I might just try to subtract them. This one has water in it. That one doesn't, right? So if I take 249.71 and I subtract the 159.62, that basically takes this from that, and the only things left is the water. So I'm going to subtract that to find out my mass of my water. What was it?
9009.
90.09? And now what the question is really asking for is how many moles of water molecules are present in the hydrated cupric sulfate. So this N value here is a mole value. How many moles of water are there? How do I change grams into moles from before in these notes?
You have to do the 6.022 thing, right? Railroad tracks.
I'd have to use railroad tracks for sure. But I just want to change grams into moles. So I'm going to use a molar mass, right? Did we have the molar mass of water in these notes? I think we did on the other side.
6.022. Oh, no. That's the other one.
240 grams.
It was right here.
Oh, 18.02.
18.02 grams per mole. So what am I going to do? Multiply or divide by 18.02?
We're gonna
So if I divide, what's 90.09 divided by 18.02? Remember, you want 4 sig figs in this answer, it looks like.
divide. 4.999.
Okay, so that's how many moles I have. Now, in reality, when you have a question like this, my answer is really supposed to be a whole number. What whole number is there, Trace? 5. There's a 5 in front of that water, right? So that answer is 5. So there's 5 waters for every one copper ion and 1 sulfate. There's 5 waters per those things. And that's what it says right on here too. So the real answer is 5. N equals 5. But sig figs, you could have had 4 sig figs. It's just in this case, in this scenario, if you're given a value for N here, that's always going to be a whole number. So you calculate it. If you don't get something that's close to a whole number, then you probably didn't do it right. Otherwise, this is pretty easy. Just subtract one from the other. That should give you the water that was basically vaporized. It's anhydrous because there's no water in this one. There was water in the other one. So when you subtract, you can find out how much water there was. Change that into moles. Figure out what it is. Got it? So that's it, right?
That's it.
Sweet.
See ya.
Now what do we do?
We're done for the day.